Geometry section 11.3, surface areas of pyramids and cones. We're starting again at my website like we did on the last lesson because I want to show you the notes here. I'm not going to be doing this all chapter, but these two sections, it is probably the best thing to do is to show you this note sheet, the most direct way for me to get information to you. And I made this document available for download if that's the way you learn and you want to take that blank sheet. If you want to pause this video right now and not look at the answers and take the blank sheet and open your book and fill things in, if that's how you learn vocabulary, I think that's a great thing to do right now. But short of that, if you just want to, if you think you can just learn as we go here, I am going to make some highlights. Again, as I said on the last video, I do think that you should look this over in more detail. I'm not just going to read this whole sheet to you though, so I'm going to hit some of the high points. So here we go. And again, this is a note shell that I would have given in class and had you fill it out using 10 or 15 minutes in class and your textbooks, maybe a partner, had you been here. Okay, so notice, again, I'm going to start with the diagrams. Those seem to be the most direct way for me to show you some things. Here you have a pyramid that has a square base. The base is the square, okay? Here you have a pyramid that the base is a hexagon, okay? And there are a lot of terms that are less important, like lateral face and the vertex of it. Now, I think they all have their place, and I don't think that there's any word that you could totally ignore. But the things that you have to know would be base, okay? Now, something I should have mentioned in the last video, I don't think I did, was the fact that the capital B is for base, and the reason for that is because it is to remind you that it's an area, that it's something two-dimensional. Of course, we have used the lowercase b to also mean base. The fact that it's capitalized is to say, hey, this is an area. So in our formulas, both in the 11.2 formula and here and going forward, when you see capital B, that means base, and it means an area of a base. It means a two-dimensional figure, not just one, okay? Secondly, and also extremely important, is that you understand what the L here is. That stands for slant height. I assume that they didn't want to use S because S can somewhat look like a 5, and also you have side that starts with S. So I think they just went with the second letter in the word slant. I think that's what they did for that, to name that length. And it basically goes from the tip top of the pyramid, that's called the vertex, down to the midpoint of one of the edges of the base. That is that length. And notice that it's perpendicular. That would be always the case. It's perpendicular with the edge of the base. And it is the letter L. It's called slant height. It should not be confused with height. And you can see it's not the greatest scan here, but you can see that little dashed line right there. Also on this one, you can see a little dashed line that goes straight down that's perpendicular with the base. That's the height, right? That would be lowercase h, not capital, lowercase h. And L is something different than that. L is on one of the faces. It's the slant height, and that's going to be needed in our calculation. Okay, it's needed in the calculation for lateral area. LA is lateral area, and it's 1/2 perimeter times slant height. P is perimeter of the base, so we'll be able to add those numbers up. Here you'd have a square, so all I'd have to do is have one of those lengths, and I can multiply it by 4, or that number plus itself, plus itself, plus itself. Same thing times 4 would give you the perimeter, okay? So again, LA, capital LA, stands for lateral area, and it's 1/2 perimeter times the slant height. And then notice that the surface area, which would be the lateral area plus the base, is there. Well, that's the formula, lateral area plus the base, okay? So the lateral area would be, on this one, the 4 triangles, and the surface area would be the 4 triangles plus the base. On this hexagonal pyramid, it would be the 6 triangles. That's the lateral area, the 6 triangles, and then the surface area would be the 6 triangles plus the hexagon itself. So if we're asked for a surface area, we're going to have to do the lateral area, which is 1/2 perimeter times slant height, and then we're going to have to add that to the area of a base, which is a polygon, which we learned in chapter 10 how to find the area of. This is why chapter 10's material came before what we're getting to now. Looking really quick just to see if there's anything else that I need to get across to you. Again, read through this. There's an example here, but we're going to do some examples anyway. So I think that's all we need for right now. And then let's just go ahead and put those in notes officially then. The lateral area, again, we're talking about pyramids and cones. The lateral area is 1/2 perimeter times slant height. and then the surface area would be that lateral area plus a base. Okay. Now, basically what that's saying is that this calculation would get plugged in here. Okay. Now, two other things. I've said it's of pyramids and cones, and you haven't really seen a cone yet. Well, we take the same tack with cones as they relate to pyramids as we did with cylinders as they related to prisms. A cylinder, you'll remember, was just a round prism. We're going to take the same tack here, and we're just going to say that a cone is a round pyramid. If you stop and think about that, what is a cone? A cone is something that has a point and it has a base, and it's just, instead of having lateral faces, plural, that are polygons, it's just one smooth surface. That's what a cone is. Okay, so we can use the exact same formulas. It basically cuts the amount of formulas down when we do this. Okay, the other thing that I think I just need to bring up, because somebody may wonder, why is it 1b here and in the last lesson it was 2b? Pause the video and think about that if you want to. Why 2b in the last formula in section 11.2 and only 1b here? It's obvious. And the obvious answer is because there's only one base. A pyramid does not have two bases. A pyramid has one base. A cone does not have two bases, only one. It's the circle, as opposed to prisms and cylinders, which had two bases. So why is it the surface area this way? Well, because we're going to find the lateral area, and then the only thing that would be left in the surface area that's not the lateral area would be the polygon that is the base. Okay, so some examples. This one says find the surface area of a square pyramid with base edges 7.5 and a slant height of 12. They did label this for us. So what we would have to do then is calculate the surface area by using this information. Now, before I do it, let me show you something real quick. Here's their formula for lateral area. They get 180. Then we're going to get a formula, or a calculation, if you will, for the base. And then they're going to bring those two things together. Surface area is equal to lateral area plus the base, and then they plug the numbers in, and then they bring them together. This seems like a lot of work to me. This seems like more work than is necessary. And what I modeled for you in 11.2 is exactly what I'm going to model for you here. I think you should adopt this. I think this is good for you. Not just for me as a grader. Of course, it is nicer to grade when I can follow your work in one concise work pattern. But also for you, I think this will be better. So start with surface area is equal to lateral area plus a base. And then immediately plug in 1/2 perimeter times slant height for the lateral area. And then you could also even plug in the area formula. I'll just use S for side. Make sure you know what that stands for. That's S. I could have drawn a better S too, couldn't I have? Square, right? That's a square. They told us it was a square pyramid. Okay? And then plug in all your numbers. Now, you may not write this line, but make sure you plug in all the numbers accurately. The perimeter would be 7.5, 7.5, 7.5, and 7.5. That would be 7.5 times 4, which is 30. The slant height is this 12 right here. Notice where it is. Notice it's not the height. The height would be like this, right? And if it was like this, we'll see on the next example, we would actually have some more calculating to do using the Pythagorean theorem. Back to the formula. Plus, the area of a square is just the side length squared, 7.5 squared. Okay? And then use your calculator if you need to. Half of 30 is 15 times 12 would be 180. 7.5 squared, I remember, is 56.25. And then as you add those up, that would be 236.25 feet squared. We're still dealing with area. It's a surface area. And when we're dealing with area, the units are not cubed, they're just squared, feet squared. Hey, quick note, I just thought of this. This isn't in my teaching plan, but just a quick note. Don't do this. Don't do that. Okay? You may have heard somebody say square feet rather than feet squared. I don't mind if you say square feet, but the units are still like this, right? Feet to the second power. You do this, it looks like you're squaring the number. Don't do that. Next one says find the lateral area of the hexagonal pyramid below, round your inch to the nearest whole number. Notice it said lateral area, right? So I don't have to start with surface area equals lateral area plus a base. If I were asked for the surface area, I would calculate the lateral area, and then I'd have to find the area of this hexagon, which we know how to do because of section 10.3. but they didn't ask for that. Lateral area is 1/2 perimeter times slant height. Now, notice something. There is no slant height. They didn't give it to us. This length right here would be the slant height. I call it L. Again, side note, the reason why L is cursive is because I don't want it to look like a 1. The book does the same thing. We don't want you to think that's a 1, so we do that cursive. And as I point to that, that cursive L is pointing at this length right here, which is the slant height. Now, do you notice that you have a right triangle kind of sectioned out in that pyramid? So we could do the Pythagorean theorem, 4 root 3 in parentheses squared plus 20 squared equals L squared. Okay? Now, use your calculator if you need to, but we do want an exact value from this to plug in for our L. And I won't use my calculator yet, but yet I'll remind you that when you square a product like this, you square the 4 and you square the root 3. So that'd be like saying 16 times 3, and then 20 squared is 400. 16 times 3 is 48, plus 400 would be 448. L squared is equal to 448. That means that L is equal to the square root of 448. Now, again, if you want to use your calculator, you can, but make sure you use the exact value that you get on your calculator right now when you take the square root of 448. I think it's just better to leave it. The perimeter, there's 6 sides that are all 8 meters. That'd be 48. And then the slant height is just the square root of 448. Now, if you saved using your calculator until now you need your calculator. And I'm using mine as well. And I get 507.98 and on. They did say round to the nearest whole number, so that'd be 508 meters squared. Okay, a couple more examples. Find the surface area of the cone in terms of pi. That's often the case with round stuff, is they'll leave it in terms of pi. If they say round to the nearest, then you should use the pi button on your calculator. This one's going to be easier than that. Here you got surface area is equal to lateral area plus a base, right? And the lateral area itself is 1/2 perimeter times slant height, so I'll plug that in. 1/2 perimeter times slant height plus the base. Now I'm going to plug in all the circle stuff on this step. The perimeter, process this, don't check out in the last couple minutes. This is important that you hear this. The perimeter of the base. The base is a circle. The perimeter of the circle, we call that circumference. So what goes in for P is 2 pi r. The slant height was given as 13. Well, I'll do that on the next line though. So L plus B. Capital B stands for the area of the base. The base is a circle. We have a formula for that. We learned about it in chapter 10. It's pi r squared. This was circumference. This is the area of the circular base. Okay, now I leave it 1/2 times 2 pi, and then the r is 5, and then the L is 13. I say I leave it because I know that many of you are going to go 1/2 times 2, that's 1, and then just knock it out. Okay, that goes along with what the book would do, which is to give you a separate formula for a cone, because I'd like you to derive it from this and this, right? 1/2 perimeter times slant height for the lateral area. I just leave it there so that's still emphasizing what the formula is. If you leave it out, if you let the 1/2 knock out the 2, fine. And plus pi r again, which is 5 squared. I will simplify. 5 times 13 is 65. So the lateral area is 65 pi. The area of the base is 25 pi. And that means that the surface area would be 65 pi plus 25 pi, which would be 90 pi. Okay. Now, do you notice something? Everything that's here is lateral area. Everything that's on the outside here is the area of the base. And then on the last step, but all in one calculation, I get my surface area, which is 90 pi inches squared. That's our answer. Okay, and then finally, we don't need to do this example because it's very, very similar to example 3. I just want to point something out to you. It says that Leandre uses paper cones to cover her plants in early spring, and then it gives us some things, some information. My question is just conceptually, if you understand, then I'll have confidence that you understand the lesson. Would we be looking for the lateral area here or the surface area? Leandre uses paper cones to cover her plants in early spring. Well, you would be using the lateral area, right? Because surface area would include the base, and if you had a base on your cone, you wouldn't be able to put it over a plant, okay? So this would be a situation where you're finding the lateral area. Anyway, good luck on your homework. Thanks for tuning in.